Everyone involved with drilling and testing of oil and gas wells should be aware of one of the most toxic elements in produced well fluids, hydrogen sulfide, or as it is more commonly known, H2S. All precautions should be taken to provide protection and safeguards against the potentially lethal effects of H2S, and for you to be aware of the safety procedures which are specific to the location at which you are working. Not all wells contain H2S. However, if you are operating in wells either suspected or known to contain H2S, you should know what H2S is, how dangerous it can be, the contingency plans for detecting H2S whilst drilling, and the breathing apparatus, gas detection, and equipment which should be provided for your safety. So what exactly is H2S? H2S is a highly toxic, deadly gas which in significant concentrations can paralyze your lungs, render you unconscious, and cause death within minutes. It is colorless and therefore can't be seen. It burns with a blue flame, producing sulfur dioxide, SO2, which is also a highly toxic gas, and it forms explosive mixtures with air or oxygen. It is heavier than air and tends to settle in low-lying areas. But fortunately is readily dispersed by wind or air currents. At low concentrations, H2S has a very distinctive smell, like rotten eggs. We must stress this is only at low concentrations. At higher concentrations, the first thing to go is your sense of smell. As the concentration increases, the gas goes through your lungs, into your bloodstream, and paralyzes the nerve centers of your brain which controls your breathing. Your lungs stop working, and you're asphyxiated. Don't depend on your sense of smell to detect H2S. You can only smell it at low concentrations. H2S concentrations are measured in parts per million. As you will see, these are the effects and symptoms of the gas as the concentration increases. At 0.10 to 0.15 parts per million, it has a minimal perceptible smell of rotten eggs. At 5 parts per million, an easily detected moderate smell of rotten eggs. At 10 parts per million, the start of eye irritation. At 25 parts per million, it has a strong, unpleasant smell. At 70 to 150 parts per million, coughing, eye irritation, and loss of smell after 2 to 5 minutes. At 200 to 300 parts per million, acute conjunctivitis, eye inflammation, and respiratory tract irritation will occur after 1 hour of exposure. At 500 to 700 parts per million, loss of consciousness and possibly death in 30 minutes to 1 hour. At 700 to 1,000 parts per million, rapid unconsciousness, breathing stops, and death. At 1,000 to 2,000 parts per million, immediate unconsciousness with early cessation of breathing and death in a few minutes. Death may occur even if the individual is moved to the fresh air at once. The effects of exposure to H2S may vary depending on the length and number of times you've been exposed, how much dosage you've been exposed to, and whether you are particularly susceptible to the effects of this highly toxic gas. The occupational exposure level set for H2S for a period of 8 hours is 10 parts per million. This is the level of concentration of H2S in the air to which you can be continuously exposed without harmful effect. To put it more simply, this represents 10 seconds out of 11.5 days. Contingency plans should be in place to minimize the risk of exposure to H2S and are in addition to the general safety procedures. These should identify important factors such as whether there is a likelihood of H2S during the various stages of a drilling program, and the incidence of H2S being more probable during drilling operations through certain sections of the well. Where the incidence of H2S is known, there is a much greater risk of exposure during certain processes, such as circulating the well, coring, well testing, and wireline work, during which fixed or portable detection and monitoring equipment should be provided. The identification of all areas where there is an increased risk of exposure to H2S is very important, such as the bell nipple, shaker room, mud pits, driller's console, rig floor, mud logging unit, air intakes on the living quarters, and test area, where fixed or portable monitoring equipment for H2S should be provided to determine the status at these locations, with particular emphasis being placed on areas of poor ventilation. All actions to be taken when H2S is detected in stream or in the air by monitoring equipment should include the identification of safe briefing areas, taking into account the installation, design, orientation and wind direction, the provision of breathing apparatus, gas detection, wind socks, flags, and associated equipment, and a plan of action for essential and non-essential personnel for the various levels of H2S alarm, and any remedial action to be taken if an alarm condition persists or worsens. A plan of action is essential for the rescue of persons exposed to H2S, which identifies rescue team members, their duties, responsibilities, and actions to be taken. As you can see, a comprehensive contingency plan is essential to minimize the risk of exposure to H2S. However, contingency plans are of little value unless they can be implemented. Training and induction briefings are therefore essential to make sure everyone knows what to do in the event of H2S being detected, and should cover the dangers of H2S and the areas where it is most likely to accumulate, breathing apparatus and the donning and use of airline escape and rescue sets, types of portable gas detection equipment and how to use them, alarms and actions to be taken in an alarm situation, musters at safe briefing areas, and evacuation drills. Rescue drills should be carried out regularly to make sure the rescue team members are familiar with the rescue procedures and provide them with essential practice. The buddy system, working in pairs, should be used when H2S is present, and should be practiced to make sure everyone is familiar with the procedures of working masked up. The importance of wind direction is very important when H2S is encountered, and the safest areas are normally upwind from the incident. Look for the wind socks and flags to establish the wind direction. In the event of someone actually being exposed to H2S, they should be returned to the fresh air immediately and receive the correct medical attention. To implement the contingency plan, breathing apparatus is required, which is normally of the automatic positive pressure type, providing a high level of respiratory protection and preventing the ingress of any H2S. Escape sets providing a minimum of 10 minutes self-contained breathing air supply should be provided for everyone. These sets are only for escape and must never be used for work or rescue purposes. A cascade airline system, together with a compressor for replenishing the bottles, bottled air banks, an airline system, and masks should be installed on the drill floor and test areas for personnel carrying out essential work on the drill floor, or for shutdown work in an emergency which requires a prolonged supply of breathing air. A continuous air supply is provided by the airline system. However, in the event of H2S being detected, the compressor automatically shuts down, and the air supply is transferred to the cascade bank for the supply of breathing air. These airline sets have a built-in breathing air supply and can be disconnected from the airline system if escape or evacuation becomes necessary. Self-contained rescue sets, which provide 30 minutes supply of breathing air plus a 10-minute supply for evacuation, should be provided for use by members of the rescue team, and also for evacuation of certain personnel from areas where it is impractical to provide an airline supply, such as pressurized cabins. Also for personnel in areas which are more remote, such as the crane or monkey board, where an air supply in excess of the normal escape set is required. There should be a sufficient number of portable H2S gas detectors, which are preferably of the continuous monitoring type and provide you with a localized reading. If H2S is encountered, the detector will automatically alarm at 10 parts per million. Evacuate the area immediately and advise others to follow. The contingency plan will then be implemented to investigate the source of the H2S. Other types of gas detectors may also be used which monitor the levels of several gases. For example, flammable gas, oxygen deficiency and enrichment, and H2S, and are generally carried by essential personnel who will determine any appropriate action to be taken if any of the gases are found. As we mentioned previously, when H2S burns, and during flaring operations, sulfur dioxide, SO2, is produced, which is even more toxic than H2S. It is therefore advisable for some SO2 detectors to be provided. Other equipment which should be provided include resuscitator ventilators over and above those normally deployed, with sufficient cylinders to cope with any emergencies. Safety harnesses and stretchers should also be located adjacent to the risk areas and ready for emergency rescue. When H2S is detected and everyone is masked up, communication can be difficult. Writing materials should be provided in all risk areas to make communication easier. However, you may find that there are special helmets incorporating a breathing air supply and a radio set. These are to improve communications and normally only for use by personnel with essential emergency duties. Working with H2S is a serious business. For your safety, always treat H2S with respect and take all the appropriate precautions. Make sure you study, understand and follow the contingency plans and procedures at any location at which you're working where there is a risk of exposure to H2S. They are for your safety.